All right, moving on to question 6. 7 marks looks scary, but to be honest, it's not that big of a deal. Let me move this over here. For these kind of questions, I'd like to write out all the forces. So first, let's split this into the horizontal and the vertical axis. So P, let's denote this as PH, and then this as PV. So horizontal and vertical portion of the P vector, and then we have another pointing down, which is G. Oh, this is W here, given in the question statement, and we also know that there's a friction acting on it because it's a rough surface. So let's write here, this is F. And finally, we know that since this ball is not moving, then that means there must be an upwards reaction force. And that is right, acting up. And if there wasn't a reaction force, the ball would be dropping down, right? Now let's try to do something here. We know that R must be equal to PV plus W. Why? Normally, if there's not a PV, R will equal to W, right? But here, since there's another force acting downwards, and we have to think about this way. If we have a ball on a table, and we try to push the ball down, we are applying a force on it, right? The weight of it doesn't change, and we are just applying another force on it. So we're adding more force on it. By Newton's second law, that means it should go down. It should have an acceleration pointing downwards, but no, it doesn't fall through the table, right? It still stays on the table. That means the reaction force must have gone up. And this is the reason, because the reaction force would immediately equal to the force that you applied onto the ball. That's basically the analogy. If you don't understand, that's fine. Just think like this arrow must equal to the sum of these two arrows. What else? Now we know that F must equal to PH because it's not moving, right? This one's obvious. And now the hard part, I would think, is we have this tangent angle, which is kind of hard to deal with. So what I would do is alpha would equal to inverse tangent of 4/3. And you could plug that into the calculator, and then you can find sine alpha of sine this, right? If we sine both sides, then you would probably get this. Now don't do it this way. Don't compute this. Like, don't plug in calculator tangent -1 4/3. You have to plug in sine of tangent -1 4/3. This way you don't get decimals, because if we just do this, we'll get some number, and then if we plug another number here, we would get like an approximation to 4/5. If that makes sense. I don't know. If we do cosine, it's the same way. We will get 3/5. Now with these numbers, I think we can start calculating some stuff. We know that PV would equal to, let's see, phi is here, right? Let's move this arrow to the left, then we will see that this is the angle alpha is facing PV, right? So that means we use sine. So PV will equal to P sine alpha, which is 4/5 P. And then PH will equal to P cosine alpha, which is 3/5P. And then, so R would equal to what? 4/5P plus W. And then we know the friction is equal to mu R. And then we know it's 1/4 times 4/5P plus W. And we know that friction must be less than, or wait. Should it be less than or equal to? Oh, it should be more than equal to P 3/5P, which is pH, right? Alright, you might be asking, why is it more than equal to? Let's think about it this way. If it's less than equal to this number, which is pH, then that means pH is larger than the friction. That means the horizontal portion of this vector right here, this arrow right here, would be enough to push the ball towards the right, because the friction towards the left is not enough. So if we do some math here, 1/5 P plus 1/4 W is more than equal to 5. Why did I write cosine here? What the hell am I doing? This is P. And then 2/5P less than equal to 1/4 W. And then we move it up, so P less than equal to 5/8 W. Yeah. And what do I want to say? I think for these kind of questions, you just have to draw all the forces out. It's not particularly too difficult, I think.